Hello everyone! With regard to general embryology, we have learned about germ cells, fertilization, blastocyst formation, and implantation. Do you remember the time of implantation? It starts from 5 to 6 days and ends at 11 to 12 days after fertilization. In fact, in the process of implantation, the inner cell mass continues, proliferates, and differentiates, forming two layers of cells, which are called bilaminar embryonic disc. And at the end of the third week, the trilaminar embryonic disc is formed. Formation of bilaminar embryonic disc. During the second week of implantation, the inner cell mass proliferates and differentiates gradually, forming a disc-shaped embryonic disc, which is composed of two layers, also known as two-germ layer embryo. A layer of columnar cells adjacent to the trophoblast is the epiblast, and a layer of cuboidal cells near the cavity side of the blastocyst is the hypoblast. The two layers are close to each other, with basement membrane between them. The embryonic disc is the primordium of human development. Look at this slide. On the 7th day, the yellow cells, a layer of cuboidal cells, is the hypoblast. On the 8th day, the epiblast formed, which is a layer of columnar cells near the trophoblast, the blue cells. On the 9th day, you can see the embryonic disc composed of two germ layers. On the 12th day, we can see that the bilaminar embryonic disc is growing. Then, because of proliferation of the epiblast cells, there is a small cavity filled with liquid, which is called amniotic cavity. And the liquid in the cavity is amniotic fluid. The shape of a layer of epiblast cells adjacent to the cytotrophoblast is flat, and they are called amnioblast. They form the earliest amniotic membrane and wrapped amniotic cavity together with the rest of the epiblast. The sac they form is called amniotic sac. The epiblast forms the base of amniotic sac. The cells around the hypoblast grow and extend to the ventral side, forming another sac surrounded by a single layer of flat epithelium cells named yolk sac. The hypoblast forms top of the yolk sac. Amniotic sac and yolk sac protect a nourished embryo disc. Look at the 8th day. A small cavity between epiblast and the cytotrophoblast, amniotic cavity, the pink color letters. On the 12th day, you can see amniotic sac and yolk sac, two cavities, which divided by the epiblast and hypoblast. This animation shows you the formation of bilaminar embryonic disc. Formation of the extra-embryonic mesoderm. There are loosely distributed stellate cells and extracellular matrix in the blastocyst cavity, which are filled between the cytotrophoblast, yolk sac, and the amniotic sac to form the extra-embryonic mesoderm. Then, there are cavities between the cells of the extra-embryonic mesoderm, and the cavities gradually converge and increase, forming a large cavity called extra-embryonic coelom. The extra-embryonic mesoderm is attached to the inner surface of trophoblast and the outer surface of the yolk sac and the amniotic sac, respectively. The extra-embryonic mesoderm that lines the cytotrophoblast and amnion is called extra-embryonic somatic mesoderm, and that covers the yolk sac is called extra-embryonic splenic mesoderm. From the next day to the 12th day, you can see the formation of extra-embryonic mesoderm, and on the 12th day, some small cavities are formed in the extra-embryonic mesoderm. This animation shows you the formation of extra-embryonic mesoderm. The pink part and the extra-embryonic xylem are large cavity. In this slide, from the bottom to the top, you can see a large cavity extra-embryonic xylem. The yellow one is yolk sac, the blue one is amniotic sac. With the expansion of the extra-embryonic xylem, the amniotic sac and yolk sac on both sides of the dorsum and the ventrum of the bilaminar embryonic disc are only directly connected with the trophoblast by a small part of the extra-embryonic mesoderm, which is called the body stalk. The body stalk will develop into the main component of the umbilical cord.